D-2 Inc Oceanography News.
But night is long, the siren song still calls me young. The fading candle is growing dim, so water pull me.
Recent study shows how the ocean is getting darker. The darkening of the global ocean. The photic zones of the oceans, where sunlight and moonlight drive ecological interactions, are one of the most productive habitats on the planet and fundamental to the maintenance of healthy global biogeochemical cycles. Ocean darkening occurs when changes in the optical properties of the oceans reduce the depth to which sufficient light penetrates to facilitate biological processes guided by sunlight and moonlight. The study analyzed a 9-kilometer resolution annual time series to quantify whether the oceans have darkened over the last 20 years, and the impact of this on the depth of the photic zones around the world increased across the global ocean between 2003 and 2022, resulting in photic zone depths reducing by more than 50 meters across 32 plus million kilometer square by area. The depth of the photic zone has reduced by more than 10% across 32 million kilometer square area of the ocean. The analysis indicates that ocean darkening is not restricted to coastal regions, but affects large swaths of open ocean. A combination of nutrient, organic material, and sediment loading near the coasts and changes in global ocean circulation are possible causes of increases in primary and secondary productivity that have reduced light penetration into surface waters. The implications of ocean darkening for marine ecology and the ecosystem services provided by the surface oceans are currently unknown, but likely to be severe.
Professor Tim Smythe, and he's with us from Plymouth, England. He's the head of marine processes and observations at the Plymouth Marine Laboratory.
As you can see, CNN recently covered this report as well because of the massive impacts this could have on coastal communities and the fisheries. Recent years have seen growing concern over the ecological impacts of greening and darkening observed in coastal regions. The attenuation of natural light by elevating concentrations of plankton suspended in particulate matter, colored dissolved organic matter, or other optically active constituents in seawater is reducing the amount of light available for photobiology in the oceans. This affects the largest daily migration of biomass on the planet. The darkening of the global ocean represents a reduction in the depth to which photobiology driven by the moon and sun can take place, and as such constitutes a globally widespread form of habitat loss that remains unquantified.
Light is absolutely fundamental to the way that the oceans operate in terms of the processes that go on in terms of the biology that inhabits it. So, any changes to the way that light operates there should be of concern.
The results of the study have been published. You can see changes in light attenuation. K490 increased across 75 million kilometer squared, 21%, and decreased across 37 million kilometers squared, 10% of the global ocean between 2003 and 2022, indicating that the oceans have become darker over the last 2 decades. In this figure, darkening of the global ocean, the rate change units per year in the diffuse attenuation coefficient for downwelling irradiance at 490 nm, measured from the Modus Aqua between 2003 and 2022, in 9-kilometer resolution. Reds indicate regions where K490 is increasing, oceans are getting darker, while blue indicates regions where K490 is decreasing, oceans are getting lighter. White indicates regions where there was no statistically significant change in K490 over that period, 2003 to 2022. Changes in photic zone depth. When considering photobiological processes guided by sunlight, the photic zone has reduced by more than 100 meters across 9 million kilometers square, 2.6% of the global ocean. between 2003 and 2022. The area reduced by more than 50 meters depth was 32 million kilometers square, 9%, and the area reduced by more than 10 meters depth was 68 million kilometers square, 19% between 2003 and 2022. The average depth of the photic zone during daylight was reduced by more than 50% across 369,000 kilometers square of the ocean area, and by more than 10% across 32 million, about 9% of the global ocean.
Process of ocean darkening, and we think that is caused mainly by changes in agricultural practice, things like the introduction of more nutrients into these coastal zones, which then feed things like phytoplankton blooms, that you've got river runoff, which is changing the dynamics of the suspended sediment, for example, in the water.
Figure 2, loss of the global photic zone. Changes in photic zone depth in meters between 2003 and 2022 under sunlight A and C and full moon B and D irradiances. Changes in delta Z photic expressed as a percentage difference to 2003 are given in figure S1. The photic zone was defined as the depth at which the minimum radiance of 400 nm light occurs that elicits diel vertical migration in Calenius copepods. Surface irradiance at zenith were modeled at 9 km resolution for the median day in each month of a typical year and used to quantify delta Z photic zone with the annual average presented. The area of the global ocean, 10,000 kilometers square across, which Z photic IS is reduced by 10 meters increment depths, is presented in C and D. Red corresponds to reductions in Z photic, while blue indicates increases. The dashed line gives the total area of deforested land cover since the year 2000 as a point of reference. A breakdown of C and D by IHO region can be found in tables S5 and S7.
The more open oceans, and what we believe we're seeing here, because we've got satellites now that have got sort of 20, 30 years of time series, that we can see this change in the open ocean that we wouldn't have seen before, because we would have been dependent upon going out and measuring with ships. So what we're seeing in the open oceans is likely due to changes in the plankton dynamics, so the phytoplankton that form the top of the food chain, that they may be blooming much more intensely and in different areas and at different times, and that's causing the changes that we're seeing within the satellite pictures.
This paper ends with a discussion. The surface oceans have changed color over the last 20 years, indicating global scale shifts in ocean ecology, caused potentially by blooms in phytoplankton and zooplankton. Our results provide evidence that the global ocean has also become darker over the last 20 years, and this has resulted in a net loss of photic zones at large spatial scales. Darkening of the ocean has recently been implicated as a driver of changes in the timing of phytoplankton blooms and reproductive phenology in cod. Changing underwater light regimes caused by darkening could result in the mismatch of phenological events and the erosion of both the diel and vertical light niches that are critical for partitioning ocean biodiversity in time and space. A key example is the vertical migration of zooplankton, the largest daily mass migration of biomass on the planet. It will likely be compressed to shallower depths in darker waters. Without sufficient light with which to grow, move, hunt, communicate, reproduce, and photosynthesize, marine organisms will be forced to migrate vertically into an increasingly smaller belt of sufficiently lit surface waters, exposing them to higher levels of competition for resources and elevated risk of predation. The implications for marine food webs, global fisheries, carbon and nutrient budgets could be severe.
I think the key thing to do is to keep monitoring this to see whether or not this is part of a long-term change or something that's just part of a natural cycle.
Did you know that most volcanic activity actually took place under the ocean? Scientists stumbled upon an active volcanic eruption in a mid-ocean ridge for the first time ever. From a research submersible, scientists saw hardened lava, dead tube worms, and orange flashes from an eruption in the East Pacific Rise. For the first time, scientists have witnessed an active seafloor volcanic eruption along a mid-ocean ridge. The team exploring underwater from the research submersible Alvin caught the rare sighting while on an expedition off Costa Rica to study the Taika hydrothermal vent. Deep-sea hydrothermal vents like Taika are opening on the seafloor where heated, mineral-rich water is released into the ocean, allowing unique ecosystems to thrive around them. On April 28th, the eastern Pacific waters near Taika looked just as scientists would expect, brimming with life. The team saw tube worms, mussels, crabs, fish, and other animals swimming around the vent, but the next day, the landscape was barren. My brain was trying to understand what was going on. Andrew Wozniak, a chemical oceanographer at the University of Delaware, who was on the submersible, tells Maya Wei Heiss at the New York Times, "Where did things go?" Eventually, Wozniak and his team noticed hardened lava covering dead tube worms and realized what they were witnessing. They were looking at the result of a volcanic eruption. In the distance, they spotted orange flashes of molten lava being released and hardening as they hit the cool water. When we saw an orange shimmering glow in some of the cracks, it confirmed that a volcanic eruption had taken place and was still actually underway. Alvin's pilot, Caitlin Berdshear, says in a statement, "After some time, though, they chose to end the dive and bring the submersible back up. We have temperature limits to ensure the safety of the sub and its occupants," Berdshear explains in the statement. "I kept a close eye on the temperature as we were traveling, and it kept climbing higher, until I decided it was a good idea to leave before we reached the limit." Though the Alvin team had cut their expedition short for safety reasons, they collected as much data as possible. They deployed scientific instruments and maneuvered bottles to gather samples for further research, says Sunita Shah Walter, a marine scientist at the University of Delaware, in the statement. "It doesn't feel real at the moment, but to be able to observe what we saw and be able to collect samples is really mind-boggling," adds Wozniak, chief scientist of the expedition. In the statement, "I'm so excited for my team, and I'm really excited to see what we can learn about what's happening down there." Only 2 other underwater eruptions have been observed in real time before, and neither of those happened along an ocean ridge, but a staggering 80% of our planet's volcanic and seismic activity happens on the ocean floor, making it a key target for research. Bill Chadwick, a volcanologist at the Oregon State University who was not on the expedition, tells the New York Times that the sighting is a super exciting first. The Taika vent has been the subject of ongoing research since its discovery in 1991 when Dan Fernari, a marine geologist at Woods Hole Oceanographic Institution, and his team witnessed the aftermath of an eruption on another Alvin dive. The team will continue to monitor the vent in an effort to uncover more information about deep-sea volcanism. Geologists will examine high-resolution maps of the site to determine where exactly the eruption occurred, while chemists study how the vent's hydrothermal fluids changed before and after the eruption, and biologists trace how life returns to the area. All of this has to do with understanding this holistic system that is Earth and ocean, adds Fernari, who is not on the current expedition, to the New York Times. "It's so intertwined, it's both complex and beautiful." The world of drones continues to expand, especially in the oceans. Ocean robots exploring the role of marine snow and carbon storage. A cutting-edge fleet of ocean robots and instruments has been deployed to explore the depths of the Labrador Sea as part of a groundbreaking year-long experiment led by scientists from UK's National Oceanography Centre, the NOC. The Rebels project, Resolving Biological Carbon Export in the Labrador Sea, is investigating the biological carbon pump, a key ocean process that helps remove carbon dioxide from the atmosphere and store it in the deep sea, and without which atmospheric CO2 would be 50% higher. Using a combination of moored sensors, drifting profiling floats, and autonomous underwater vehicles, the project seeks to understand how carbon-rich particles sink through the water column and how physical ocean processes such as deep convection currents might enhance carbon storage in this remote and understudied region. A key innovation in the project is the FluxCam, a novel marine snow camera system designed to measure the sinking speeds of different sized particles to reduce uncertainties in how much carbon the ocean absorbs from the atmosphere. FluxCams were installed on deep-sea mooring in the Labrador Sea between Newfoundland and Greenland last year along with specially programmed drifting profiling float. Now they have been joined by autonomous underwater gliders, which will measure ocean properties and carbon flux for 5 to 6 months. The biological carbon pump plays a crucial role in regulating Earth's climate, says project lead Dr. Philippa Cavarlo at NOC. Microscopic marine plants, known as phytoplankton, absorb carbon dioxide from the atmosphere and convert it into organic material. This material is then consumed by marine organisms, with remnants eventually sinking as marine snow, tiny carbon-rich particles that settle in the deep ocean, where the carbon can be stored for centuries. Now, if we could just find a way to get that marine snow onto some of those mid-Atlantic ridges, we could all be skiing underwater. However, the rate at which these particles sink and how much carbon is ultimately locked away remain uncertain. The Rebels project is using cutting-edge technology to answer these questions. This combination of fixed and mobile instruments will allow us to track how carbon is transported and transformed in the Labrador Sea over time. Speaking of underwater cameras, the world's first footage from an Arctic marine terminating glacier front. Excited to share some incredible underwater footage from our expedition to, cannot pronounce that, Glacier on Svalbard. These impressions showcase the fascinating underwater life at Glacier Marine's terminating front. We have hours more footage and would love to connect with experts in marine biology, glaciology, or underwater robotics. If you're an expert or know one, please reach out or share. This post will be linked in the description box, so if you want to reach out to Leonard Gunzel, please feel free to do so. Geologists, stay tuned for a follow-up post with unique footage of the glacier's shape. Big thanks to Glaciomar team, along with the Safeguard Project, CB, Arctic Field Grant, and the amazing logistics team at Eunice. Here is the new Arctic underwater footage. Our next story is about how rivers fuel hurricanes and how that knowledge can improve forecasts. The story comes out June 24th, 2025 by Dylan Furness. As Hurricane Idalia approached Florida's Big Bend in August 2023, warm waters of the Gulf fueled its growth. In less than 24 hours, the storm jumped from a Category 1 to a Category 4 in a phenomenon known as rapid intensification. Idalia is not alone in the annals of supercharged storms. Recent hurricanes such as Milton 2024, Helene 2024, and Ian 2022 rapidly intensified before their devastating landfalls. In each instance, the sudden increase in strength made the ultimate impact difficult to predict. A recent study led by researchers at USF's College of Marine Science shows that water discharge from rivers can play a role in this phenomena. Data about freshwater plumes can help experts improve hurricane forecasts. Sea surface temperature, ocean heat content, and wind shear can influence a storm's sudden gain in strength. These factors alone fail to explain Idalia's intensification, according to a recent study published in Environmental Research Letters. Wind conditions during Idalia's period of rapid intensification were not as favorable as they were earlier in the storm's development, the author states, raising the question of what external factors contributed to its extreme intensification during this phase. To answer the question, the authors analyze a plume of freshwater that stretched from Mississippi to Florida's Panhandle and south to the Florida Keys, which created conditions that were ripe for intensification. Discharged from rivers along the Gulf Coast, this plume formed a thick surface layer of low-density, low-salinity water that resisted mixing with the rest of the water column. Of course, the best way to measure this mixing of salinity and temperature would be to use one of our D-2 Inc CTDs. Please visit our website and check out our oceanography products for more information. The result, warm surface water stayed warm and fueled the storm, as you can see here from this image. In late August 2023, a low salinity plume of fresh water stretched from Mississippi to the Florida Keys. Hurricane Idalia's path and classification is also shown. In a recent analysis of Idalia, researchers demonstrate how this river plume may have influenced the storm's rapid intensification. Credit NASA Earth Observatory. Water mixing is a natural process typically driven by winds, said Chuan-Min Hu, a professor of oceanography at the USF College of Marine Science and an author of the study. Winds mix warm, shallow water to the depths and bring cool, deep water to the surface. This mixing of deep and shallow water helps keep the sea surface temperatures down and remove some of the fuel storms depend on. However, during Idalia, the density difference between the fresh water on the surface and the salt water down below made mixing more difficult. The findings were somewhat serendipitous. Hu and his colleagues, including researchers from the college's Optical Oceanography Lab, Ocean Technology Group, and the University of Miami, intended to study phytoplankton and dissolved matter in river plumes using data from satellites and underwater gliders. The data they gathered on the thick layer of freshwater proved valuable in understanding Idalia's intensification. Prior studies pointed to the influence of river plumes on the intensity of tropical storms in other areas of the globe. A paper from 2007 found that more than two-thirds of Category 5 storms between 1960 and 2000 traversed the vast plumes of the Amazon and Orinoco rivers in South America. For Hu and his co-authors, a key takeaway from the recent study is the importance of integrating river plumes into hurricane forecasting. Accurate forecasting is critical for people to plan as storm approaches, Hu said. Our study demonstrates the value of considering the influence of river plumes on storm intensification. If there's a persistent river plume right in the right location at the right time, you might have the perfect conditions for a powerful storm. And once again, the best way to measure if you have a river plume of fresh water sitting on top of salt water is to use a D-2 Inc CTD. Please make sure to subscribe and like and share this video, and head over to d-2.com/news and bookmark our news page and check it regularly so you don't miss out on important updates like my recent interview with Marine Technology News. Thanks again for watching and hope you have a wonderful day.